Charlene Chant, and today we'll be discussing the fundamental laws of physics that surround bowling. Now, one of the most basic elements of bowling is the lane itself. The surface of the lane and any type of conditioning on the lane, such as an oil, will directly control the magnitude of the friction between the bowling ball and the bowling lane. The more oil, the less friction there will be, and the faster the ball will go. And the less oil, the more friction there will be, and the slower the ball will go. However, the ball will ultimately eventually slow down due to the force of friction of the floor itself. The equation to find kinetic friction is F equals mu times N. The coefficient of friction is crucial to bowlers, as will either make it easier or make it more difficult for the bowling ball to glide down the lane and achieve a strike. The conservation of energy theory is crucial to being successful in bowling. When a ball is thrown, potential energy converts to kinetic energy, and as the ball hits the bowling pins, its kinetic energy transfers to the pins, sending them into chaos and allowing more pins to be knocked over. Without the conservation of energy, bowling balls would not be able to transmit their energy across the pins and would fail to bring them all down. However, not all of the kinetic energy from the bowling ball is transferred to the pins. Some of the kinetic energy is transmitted into sound. Some of the energy during the ball's collision with the pins is transferred to air molecules near the collision, causing them to vibrate. This disturbance in the air molecules travels outward as a longitudinal sound wave and results in a clunk. So what about the initial force itself? What forces propel the ball in motion to have the ability to slide down the lane and collide with the pins? Impact, the bowler must release the ball with the force perfectly parallel to the horizon. Since the horizontal velocity is independent of the vertical velocity, any force that is not parallel to the horizontal axis is wasting energy in the vertical direction. All energy should be spent in the horizontal direction. The horizontal kinetic energy that remains after the ball has traveled down the lane is the only energy that will be used to collide with the pins. So, now we have talked about the force, the lane, the pins. Now it's time to talk about the ball itself. The angular counterpart for mass is inertia. Inertia is a quality of an object that determines how difficult it is to get that object to move, to stop moving, or to change directions. Generally, the heavier an object is, the more inertia it has. Although it is difficult to set a bowling ball into motion, it is additionally difficult to stop its motion. Therefore, it has enough inertial capacity to knock down the bowling pins at the end of an alley. Finally, one of the most crucial aspects of the bowling game is the location of the center of gravity on a bowling pin. The center of gravity is located at the lower end of a bowling pin. This is important as it is not at the very bottom of the pin, but high enough to help to stabilize the bowling pin and prevent the pins from falling too easily and keeps the game challenging. That's it for today, everyone. This was AP Physics with Charlene Chant.